Okay, a basketball's volume is about 455 cubic inches, or 7.5 times 10 to the negative third meters cubed. The planet Earth is 1.1 times 10 to the 21st meters cubed. Determine about how many basketballs could fit inside the planet Earth. Express your answer in scientific notation. So this is just a division problem. We're trying to figure out how many times 1.1 times 10 to the 21st over 7.5 times 10 to the negative third. So this is a division problem, and you could just break it into 2 bits, or you could do 10 over 21 times 10 to the negative third times the whatever 1.1 times 7.5 is. So you multiply it.
Are there any questions so far? She's going in warp speed.
Sorry. So we have to divide these exponents, and how you divide exponents is subtracting them. So you'd get the answer of this is 10 to the 24th. And then,
all right. And then once you have your 10 to the 24th, you have to do your 1.1 times over your 7.5. And then the 1.1 over your 7.5 equals 0.146. And so then that gives you, so you have to put it in scientific notation. So you have to do 0.146 times 10, which gives you 1.46. And then you have your 10 to the 24th. So then you have to multiply by your 10 times, your 10 times your 24th. And so because you're doing that, that gives you 1.46 times 10 to the 25th, because you add the extra exponent.
Are there questions?
Wouldn't you, if you're already multiplying by 10, wouldn't you take one of the 10s out of the 24 to get 10 to the 23rd, not 10 to the 25th?
Yes. So.
Okay, so how do we go back and correct that?
So, instead of 1.46 times 10 to the 24th, it's 0.146 times 10 times 10 to the 24th. And, so then you already, well, it wouldn't be 10 to the 24th, it'd be 10 to the 23rd, because you've already taken 1 10 out of there.
Those people in the video can't see your fingers, so could you write it?
Okay. So instead of this equation, it would be 0.146 times 10 times 10 to the 23rd, since you're already multiplying it by 10, so you'd have to subtract 1 from the 24th. And so that would also be, it'd be 1.46 times 10 to the 23rd. Yes, if you multiply this, then yeah. Okay. Good.
How about problem 2?
Should I erase the board? Okay.
Right. So for problem 2, Amy made the conjecture below. If a rational number...
So a rational number is a number that can be described as a fraction with whole numbers.
So knowing that, if a rational number is an integer over 100, then the square root of the rational number is rational. For example, the square root of 225 is rational, as well as the square root of 121.
What is the square root of 225?
15.
And the one of 121 would be 11. So provide 2 examples of integer numbers over 100 that show Amy's conjecture is false. So all you'd have to do is take any number that you know isn't a square number, like let's say 101, and once you find the square root of that, you a rational number has to be expressed in either 2 whole numbers and a fraction that don't have decimals, but once you do 101, the square root of 101, it's going to be 10.05. Or you could just pull up your calculator and then square root it from there. So 10.049, or you could round it. And once you do that,
The trick here is if you get a decimal that is non-repeating and goes on forever, it's a good bet that it is an irrational number. But if you get a decimal that terminates or stops, or a decimal that is repeating, it's a good bet it's rational.
so once you get this number, you can obviously tell that you can't express it in a way that has whole numbers with the fraction. So that's one example of why this is false. And another could just be if you plug in 102 into your equation and square root that. Again, you cannot you can't make this a fraction with whole numbers. You'd have to add decimals to it.
For number 3, it says eliminate the negative exponent and simplify. So first I started with 8 to the negative second, which I know is equivalent to 1 over 8 to the second, which is also equivalent to 1 over 64. Then for this, I did 16 over. So if you have a negative exponent in the top, just like we had here, it's equivalent to the positive exponent in the bottom, I guess. So it would be y to the 6th times y to the 4th. And then for z to the negative second, that's also equivalent to z to the 2nd above it, and then times z to the 5th. So then you have 16 z to the 7th, because for exponents you just add them, over y to the 10th. And then you're multiplying these two together, so you get 16 z to the 7th over 64 y to the 10th. And since 4 goes into both of these, you can divide it by 4 over 4. It goes into 16 and 4. So then you get 1 z to the 7th over 4 y, oh, not 4, sorry, 16 over 16 over 4y to the 10th. Okay.